Hi, this is Bryan.D with the final sprint again. So let's look at the terrain now. So let's take a look at the .h for the terrain first. So the .h is the, well, it's .h for terrain, obviously, sorry. I'm very tired, I've been working a lot. So we'll start off, first we have a struct for each cell. Each cell has a min and a max, and it's 4 indices. And these are just ints because they point to where in the list of vertices they'll be. And we'll take a look at that. We'll take a look at the use of that in a second. Constructors, and then the actual constructor that's going to be used. And then this is my iterator. It has a vector of pointers to cells. Yeah. That's pretty much all that does. This has the only thing that it actually owns is a pointer to the height map. It's got a lot of little methods, so let's just head in and actually take a look. Well, actually, first let's look. It has a int for the image width, int for the cell number, so number of cells total, side length. Okay, so this is cell like width, how many cells it's got sideways. This is the actual in-game distance of how far. This is the max height, and this is the y0, and then we got a pointer to the very upper corner to find from. So let's look. So in the initialize, so this is where the nav map's actually created, because how you create this is in the resource manager. You load up terrain manager. You load up the name that you want to call it, the texture for the height map, how long you want the side to be, your max height, your y0, and then your texture name. It should be already loaded in the texture manager. This isn't loaded in the texture manager because I don't really count it as being used in game, so I figure it can just be loaded straight into the terrain. So now, now that we've seen how it's loaded in, the terrain manager calls for the construction of terrain. We'll look at the terrain manager in a second too, and it calls this, and it stores these, and then in the actual scene, when you say set terrain, that's when the game actually initializes the whole terrain. So when the initialized is called, it reads in the height map and creates the whole terrain. Actually, I don't think the initialize. No, never mind. Sorry, the initialize method isn't called right there. It's called, I believe, it's called in the scene object after the yeah, in the actual initialize function. I'm trying to find exactly where it's called at, because I know it's not called there, because that would be silly. But it's also not called at the start. Anyway, I'm sure I'll find it eventually. But it's not called every time you load it, and when we step through those, you'll see that. But it couldn't be called immediately because I think the something somewhere, I'm sure as we look through here, wasn't initialized, so it had to actually be initialized a little later. Anyway, Sorry about that. So the here we can see the terrain being created. I'm not going to step through all of this. This was a pain in the butt to do simply because I wasn't in that graphics class. So I wasn't exactly positive on how to do all of this. But going through, I got it done. Cells being created with the triangles. And then we create the actual object, delete the verts, delete the triangle indexes, and submit entry to the scene because this is actually used as a drawable. As we can see, it inherits drawable right there. So the scene entry, registration, exit, deregistration. So now let's look in the actual methods. This is called to highlight a cell, uses the find cell method, and then creates a, like shows an AABB in the visualizer based off of vect. Highlight all ground cells. This highlights all the ground cells colliding with an object, or underneath an object, I should say. So it gets the collision cells, and then shows for all of them. Highlight a point on the ground. So this highlights, just you put in a point and it highlights what's underneath it. Get ground position. So this is an interesting one. So this first finds the cell that you're going to be in, and then finds what triangle the point's actually in, and then finds the plane intersection point in the math tools. It uses that, and then based on that, it returns the point X, the point Y, and the ground point. So where the actual ground intersects, and that's how I use, and this is the tool that I use to go up and down. Get ground normal. This returns the normal for the point. Get ground collision. This we saw in the collision manager. So what it does is it creates a iterator based on the ground collision, and gets the default sphere, and default sphere is actually used to get all the cells because I figure that's the biggest area that it's going to be in, so we might as well use those cells. Because if it is the B sphere, then it could be colliding with any of those cells. And then it iterates through the lists, the cell pointers in the iterator, and tests for intersection. This is the exact same method. It just has the visualizer calls in for showing whether or not it's colliding. And this is where we get the collision cell. So what I do here is I create the iterator, and then I do the quick way of getting to the cell. But the problem is sometimes this can be off by one cell or one column just because of rounding errors in the ints, because you have to store, in lists in I actually use vectors here. In vectors, I figured I'd use vectors here. I use lists and vectors for most of my storage devices in these classes. Anyway, sorry about that. So it gets the actual cell that it thinks it is, and then it does a really quick search that's basically a greedy best first search to find the actual point that it's in, and to get the actual point that the thing is in so that I can get rid of those rounding errors. And the most that this is going to go through is 1 or 2 cells based on how far it was. And it has the ability to go diagonally too, so it will go basically almost straight to the cell. And then it checks to make sure that it's within the row, that the row and the column is within the image width. If not, it returns it, which should be empty. So basically no errors, and you're not going to find any collisions. So it just quickly goes through that. And yeah, if it's not, or if it is within this, then it goes back. What it does here is it gets the cells that it's actually returning are all the cells that are within, able to collide within a B-sphere, within the B-sphere max distance, so radius. So the furthest on the Z, plus and minus, the furthest on the X, plus and minus. So it's going to return a square. Yeah. And then, so we'll go look at the find cell. This is virtually the exact same thing, except it uses this. And the reason I couldn't use this code for this code is it's fundamentally, or it's different at the end, because if it's greater, or if it's out of the image, then it puts it, or if it's out of the terrain, then it puts it back on the edge of the terrain. So you're going to find the cell on the very edge of the terrain, because this basically has to return something. Otherwise, other methods will fail. Whereas this can return an empty thing, and it will just continue on onto the next thing. So that's the end of my terrain class. So let's look at the terrain manager. So this is the non-scene level terrain manager. This is a singleton. This is what you use in the resource manager. It has a unordered map of terrains. Now, the reason I use an unordered map is because you're basically only getting and putting in terrains. So I didn't think an ordered map was necessary, because you don't have to iterate through to find things. And unordered maps, I read on the internet while I was doing some research on what volumes to use. They said that it was better to use an unordered map. So without further ado, it's got a few methods. Get the terrain, turns a pointer to the terrain. Load, unload all terrains. It's got a default terrain that it puts in terrains. And to construct the default terrain, you can do two things. You can either say, hey, this is the side, the Y0 is, and you won't have a texture. The texture will just be white. Otherwise, you can use this, and you can actually put a texture onto the default terrain. So it'll just be a white block, which we can see if we start up the project and go into the next scene, and I just have a default terrain on the ground, which I can show. So the default terrain isn't actually created until you select or until you say default terrain, because I figured you don't really need to store an extra terrain if you're not going to be using an extra terrain. So, and since the terrain only has a single cell, it is yeah, it doesn't need it's not like it's going to take very much time. So yeah, then it just puts it in. If it wasn't already in, then it puts it in. If it was already in, then it replaces it. So you can just create a new one. Yeah, runs through all the terrains, deletes them. Loads them up. So now let's look at the scene level terrain manager. The scene level terrain manager is basically just an accessor, and it stores the current terrain. So for the scene level manager, I use the null pattern, which I can show you my null terrain right here, and there's no .cpp because it basically just returns 0 or void for everything because it should never be really used. But just in case of any errors, it returns zeroed out values. But the scene terrain manager right here in the construction, it just constructs a null terrain. It then, if on set terrain, it sets the terrain, sets default terrain if you want the default terrain, and yeah, sets the default terrain with the Y inside, and this is what's actually called in the scene file. So yeah. Let's see, is there any other things I need to show? I have shown the collision, I believe. I'll show the default terrain just for reference. This is where I create the default terrain. The default terrain is created with grass texture. I can take that out actually really quick after we load this whole thing up and show that it's just plain white, basically. And then, oh, I may have turned around here. Here we go. Okay, there's the default terrain. Yeah. And then if I load up just the regular default terrain, it's just a giant white square. Yeah. So, that's fun. So yeah. Terrain was actually super cool to build. I didn't take the graphics class, so obviously I had no idea. I just realized I did not show the... I'll make a whole video showing class diagrams. That way I can just make sure that I get them all. Otherwise I'm probably going to forget one. So yeah, that's pretty cool. So on to the next video.